just in case. All right. So now the computer, how the computer processes the data? Using digital, correct? Digital is 0, 0, and 1. However, when you send the data, you're not sending it as 0, 1. You send it as signal. So you have to convert the digital data to an analog data, right? So you need a decoder. Okay? And when you receive the signal at the destination, you receive it as analog, and you have to decode that to a digital, right? So very important. All right, let me just go to another concept. Okay, so let's assume I'm trying to send data from host A to host B, correct? Now let's assume for some reason the data got lost here. So what you have to do? You need acknowledgement, correct? And acknowledgement, how if B never received it, how will B will know if there is something coming to me? So B, they will not know. B will know they're receiving something when they receive it, correct? So how you will fix this issue? So A, what's A? A will send the data, then A what will do? They will run the clock to a certain time. So after a certain time, if there is no acknowledgement came back from B, what I have to do? Resend it, correct? Now let's assume, the data received B received the data, and there is no problem. I send it, I received it, B received it. How A will know that's B received it? Correct. So B has to send acknowledge back to A. So when B send acknowledge back to A, okay. Now let's assume the acknowledgement lost. Now, what's A will do? It will wait for the response back. Then what's going to happen? The time?
A will resend again.
So as he said, A will resend the data, the same packet, send it back to B. Now B, what's happened at the B side?
B has to send acknowledgement to A.
Yeah, but B already have the package, correct? So that's mean what's B will have? So we'll have the same packet twice, correct? So now what's B will do? B will keep one copy. It's not a problem for B because yes. B will know, oh, that's a copy. I will keep one and discard the other one, correct? Then B, what will do? B send, acknowledge again. And if A received the acknowledgement, then done, right? So why I'm showing that? Showing you to communicate between two sides, what you need? You need a protocol, correct? We have to understand how we're communicating. Oh, you send me something, I have to wait to receive it. When I receive it, I send the acknowledgement. For any reason, I lost acknowledgement, A will send it again after a time. B received 2 copies. Okay, now, oh, I have 2 copies. What I will do, keep one and throw the other one. So the concept here, you have to have a standard. You have to have a protocol for 2 systems to understand how to communicate. All right. So that's why we have to learn network. We have to know about the TCP/IP protocol and the OSI model protocol. That's a standard. The organization came together and they built a protocol to understand each other and to know how to communicate. So that's why In this course, we'll go over a lot of protocols. When we go over IB protocol, we will go over TCP protocol. We will go over, for example, the network layer, transport protocol. You have application protocol. There's too many protocols to already build. Just we have to understand how these protocols work together, correct? And what else we'll have in this course? What else in networking we need? There is a way to do clean all that. It's fine. All right. Now, what is the smallest network? We said 2 computers, correct? And what we call that when you have 2 computers, for example? Local area network, correct? You know, the local area network, it's a limited area, you know, it's connected together somehow. They're not going outside, it's local, correct? Yes. So now, if I have a local area network, and for example, let's say, you know, that's the UB, all right? Then I have another area network called, don't want to confuse you guys with my camera, so I will do that. So let's say, you know, I have another local area network, and let's, you know, that's, you know, Fairfield University, correct? Okay, and you have another one. Let's say, you know, it's New Haven University, okay? And these 3 somehow they communicate, right? And when you combine more than local area network, what we call that? Wide area network, correct? Right. Now, if we go bigger a little bit, okay, when we connect USA with India, with Jamaica, with everybody, what we call that? When we have bigger picture. When we have the whole world connected together, what we call that? Internet, correct? So internet, it's a mix between LAN, WAN, you know, internet providers, everything is connected together, correct? So that's router, correct? So that's the local area network, wide area network, and the internet. Now let's talk about another concept. It's very concept. Now let's assume we have a small area network. Guys, don't worry about that. That's not going to come in the exam. Just we're talking about in general. Now we'll go over the slide. Then, you know, you will have something to read. Okay, I'm trying to give you the idea. So let's assume we have host A, okay, host B, host C, and host D, right? And let's assume they are connected somehow. There is too many technology. You can connect the computers together. So let's assume we have a router, and all of these connect through the router. And I'm trying to send data from A to D. Okay, how we will do that? What you need to be able to know the destination. What they call it? You need an address, correct? If I order something from Amazon, okay, and they're trying to send that to me, what they need? They need my address, correct? So they need something. They need identifier, exact address, you know, the house number, the street, zip code. So you need a standard. So now, you know, you need an IP address to be able to deliver a packet from A to D. So, and in the network world, what we use IP address, correct? The logic address. And usually the IP address, it's how many bits the IP address? 32, correct? So let's assume my IP address is 10.10.1.2 for A, all right? And the IP address usually is divided to 2 parts, something called network address and the host address, correct? I'm assuming that's class B. All these terms when you when you hear IP address, class B, class C, we will cover it later, right? But I'm assuming a lot of you already heard about that. You already maybe took a course similar to this course, correct? So let's, that's the first one. It's the network address, and the last two is the host address. Now, can you give me an address for the B? Remember, when you are in the local area network, you have to be in the same network, correct? Which is mean I have to have the same network identifier, correct? Then I can select another IP address. Let's say 20 here, all right? Because I'm talking about local area network. Yes, go ahead. Network identifier and host identifier. So when you have a local area network, you have to define the network itself, add address to the network. Then you need a specific address for each host. All right, that's why if you see here, 10.10 is similar here. Now, if I need an IP address to the D, what I will have, 10.net, because it's the same network, right? Then I can get any IP address. Let's say 25. Now, another question for you. If I do that, what's gonna happen? Okay, what that mean? So the same address. So is there any house in the world has the same address? It's only one. It has to be unique. So the point here, it always has to be unique. So in this case, what's going to happen? What we call it, we'll have a conflict IP address. So the network will tell you there is a conflict. So in this case, I will change it, for example, to theory. All right. So that's the network. So the data, when the data is sent from A to D, so it's going to go through router, and router will know which host I have to send the data, and we will know when we talk about the routing table, it will send the packet to the right destination without any problem. All right. So that's one network. Then you will have, for example, let's say I have another network. And let's change it. Let me change it a little bit. Okay, this network I will use okay, let's say that's 1, 2, 3, 4. I use different naming, correct? Okay, so this one we're using router, correct? That's the star topology. We'll cover it now. Okay, what this one, when you have something like this, that's the bus. We call it the bus topology. So everything connected through a common media, and there is a way to communicate. That's we call it bus. And there is advantage and disadvantage. The disadvantage here, you can only one device can use the media at the same time. All right. Router is different. Router, everybody can send to the router. Router can queue the data on the table and send the message one by one, right? So now to connect to network, what you will use router, okay, to be able to connect this to network. And that's how you establish the wide area network. All right. What else I want to give you? Is there any questions so far? That's some of the stuff I want to. Okay, let's go to another topic. So hopefully when we start going over the chapters, when you hear, some terms, you will know what we mean by that. Okay. So let's talk about media. How many type of media we have? Let's say, you have the media here, correct? We have, which media we have? The one we usually now we use more. Wireless, correct? Wireless media, and we will have the wired media. And the wired, I'm sorry, all right? So for the wireless, what type of wireless we have? Which wireless technology we use these days? What we use in the mouse here? Optic, correct? Laptop, the laptop use?
Yeah, Bluetooth.
Wi-Fi, correct?
Yeah, Wi-Fi.
Correct. What else? The TV remote we use? Infrared, correct? So there is too many different type of media. Now let's talk about the other one, the wired. What type of wired we have? We have unshielded, like this one, correct? And we have the shielded one, right? And we will have, that's the cat cables, and we will have the, what they call it, coax cable, that which we use for the TV cable. And all this media has advantage and disadvantage, correct? Wi-Fi, it's good for us because you can move anywhere. However, it's easy to get distracted or get noise or get affected. Wired is more stable and give you a long distance. However, if you have a cut for any reason, you lose it. So that's a problem. There is a limitation. You cannot, for example, you cannot, with the speed, like for example, Cat 6 or Cat 5, you can run it up to 185 meters, correct? More than that, then the signal will be weak. So there is too many advantage and disadvantage. All right, so we will hear about another concept in networking, something called DNS. What's the DNS? Domain name system. What that's mean? Close enough. Now, all the hosts or the website, okay, has an address, and usually we use IP address. But do you think as a human, you will be able to remember all these IP addresses? Okay, you will not be able. That's why we need a system to translate the IP address to a name. So when you go and type google.com, what's happened here? So when you go to your browser and type DNS, what's happened exactly? You will send a request to your domain or DNS server and ask them, I need the address of the google.com. Simple. So the DNS will send a reply back telling you, here's the address. Then what you have to do, your browser will take the IP address and send the request to Google. That's why you need the DNS. There is no way to remember what is the IP address for all these websites. If I ask you now, what's the IP address of bridgeport.edu? Even if you ask maybe the IT team here, they will not be able to tell you what. You have to go to the admin and they will tell you, correct? So that's why we need a DNS. Another concept, and that's very important, which we use all the times, DHCP. What's the DHCP? We use it every day, correct? In our computer. Dynamic integration
control protocol.
Dynamic host. What does mean?
It will host from.
Yes, go ahead. So now let's assume you have a network, and this network you have, for example, you have 100 computers. So how many IP addresses you need? You need 100, correct? If you have 100 computer, you need 100 IP address, correct? Now, let's say, each IP address costs you $10, for example. So that's mean you need $1,000, cost of $1,000 to be able to communicate. But however, assume of this 100 computer, usually only 50 will be connected at the same time. So in this case, how you will be able to save the cost for you? So you don't have to buy 100 IP addresses. You buy 50, then you will have the DHCP, and the DHCP will control of releasing the IP address. For example, you have a DHCP server now. Okay, there is no any computer yet connected. Okay, it's a brand new network. So when I turn my laptop on, what's happened here? The computer will send a request to DHCP, telling DHCP, I'm up, I need an IP address. What's DHCP will do? They will go to the table. Okay, oh, now they have available 50. Okay, I will assign an IP address to this host, and I will mark it. It's already assigned. Nobody else can take it. Right? Then the second computer comes, ask for IP, give the IP. Now let's say you have already 50 up. Okay, and number 51 turn on. What's happened here? So the SCP will send message back. I'm sorry, I don't have IP address. Right? So in this case, now your network administrator has to make a plan. So, okay, now I see there is a demand. I have to add more IPs. Then I have to add, maybe I have to add, buy more. Or when you design your network, okay, we did not talk about class A, class B, class C. Okay, when you do the design, saying, okay, I need only 256 IP addresses. Then I will use a class C. Then over time, with the time, your company grow up, say, now I will have 500 computers. So what's your network engineer will do? We will change your scope, the IP address scope, okay, to, for example, a class B to give more IP addresses. And has to be reasonable because again, when you change it from a class C to class B, it's a huge difference range. You're going from 256 IP addresses to thousands, like 16,000 IP addresses. You need that? No. So that's why the network engineer has to design your network, have to find the best way to work and give you what you need. Giving more, it's come with more risk, security risk, maintenance, a lot of things. Now, when you have an IP address and you keep it with you, okay, until when you keep it. So for a certain time, that's why you have a protocol. So DHCP usually, okay, you can set up that in DHCP, like after 4 days, you release the IP address, okay? Because if I am holding the IP address and I turn my computer off for a week, I'm not using the IP address anymore. Why you want to keep it? Let somebody else use it. So that's why DHCP will release the IP address. And you can configure that. If it's 4 days, 8 days, usually it's 8 days. So you can keep the IP address for 8 days, you release it. Then you can grab it again, that's fine if you turn the computer on. But the DHCP will release it after 8 days. All right? Any questions so far? Again, why DCC is very important. That's going to come in the exam. That's first question. Why is very important for you guys? Because it's going to give you the fundamental information about network. It will make the other courses easier. When you take security, when you take network, when you take what else? Maybe hacking. That's really, it's going to give you the concept. When you hear this word, okay, oh, I know what that's mean. All right. So we will cover a lot of area, but again, it's going to be the basic information. All right. We're not going to go deep. We'll go over some of the protocols. Okay, still we have time. All right, so let's go to over first chapter. I see some chat here. Let's see. Okay, yeah, thank you. Thank you, Sayed, for your question or reminding me. Okay. So in this chapter, it's going to be mostly history. Maybe it's boring, but we have to go over it very quick. So I need to be patient with me. So we'll go over history of the internet, and we will define very important topics, protocol and the standard. Why we need the protocol and standard? Why? To control the communication. You know, you have to have a clear, understanding how we can communicate. And not only that, we have to make sure we have a secure, I cannot talk, reliable communication, correct? And what else? What we have to make sure? We have a fast communication. You know, you don't want to send a message and it takes like 5 minutes, correct? All right, so then we will, go over, some of the organization who control the internet, how they worked, how they agree on managing the internet, and how you build the standard, which process to make an idea. You have an idea, okay? You have to follow a process to make this one a standard, correct? You cannot just say, oh, I have an idea, okay, I will make standard, everybody has to use it. No. Then, the Internet Administration, that's another organization, they control the internet. Okay. Mostly we already mentioned that. When we communicate, we sharing information. So communication is sharing information, exchange information between two systems. And this communication could be local. What's mean local? Give me an example of local communication. Computer, between the computer and the monitor, correct? That's a local, it's direct connection. And it's remote connection. When I do sharing information from computer to another computer, that's remote, correct? Okay, what's the type of information or data we share? There's too many, either voice, text, there's too many. And now with this day, there is more, right? Video and numbers, text, everything. So to have, and I mentioned that, to have a communication process, you need elements. And we mentioned that, what we need. We need, I'm sorry, I used my hand, which is, okay. You need sender, you need receiver. What else you need? You need the message. Even if two computers already connected, okay, if there is no data going back and forth, there's no communication. And you need the media. And what else we need? Protocol. It's very important. Without a protocol, you cannot communicate. Okay, like now we have a protocol. I know I'm teaching and you're listening to me. When I talk to you, nobody is supposed to talk to the person next to him because that would distract the class. So that's the rule. Okay. When our class starts 6, I have to start 6 because some people they have to catch the bus because that's every semester happening. Because people they have to catch the bus, so I have to finish on time. So I will do my best. All right. Now let's talk about the data flow. That's concept. Now you will have what they call it simple or simplex communication. What that's mean? That's when all the times the data is going from a source to destination. Okay, so that's how the computer and the monitor. The data is going from the computer to the monitor, right? There is no way the data coming from the monitor to the computer. There's only one way, right? Same thing. The second one is the two-way. It's half duplex. What does mean half duplex? It's gonna be in the exam. What? So it's only happening in one direction at the same time. So you cannot speak and listen at the same time, correct? Or both. So if A sending data, B has to wait. Okay, when A finish, B now can send. So it's both direction, but only one can talk in the same time or send data, right? Now full duplex, which that's the common technology now, when you can send and receive in the same time. I'm sending and receiving in the same time. So that's the full. All right, so we went over some of this topology already we talked about. So what's point to point? Point to point, only two hosts connected together, all right? A and B, nothing else, okay? And that's usually when you talk about when in the backbone, when you connect like university to a router, for example, it's usually from one point to another point, nothing else, Then multi-point, what's the multi-point? It's the same idea. You have the server and multiple devices connected to the server. Perfect. Okay, what about the fully mesh technology? So what is the advantage of that? So you can talk to multiple computers at the same time, right? But what is the disadvantage? Yeah, traffic, because no, but traffic maybe no. Is the hardware. Because now, if let's say I have five computers, okay, how many network cards I need? You need
five.
You need four. Because I need one network card to go one here, one here, one here, one here. So each device need four network cards, right? And how many connection you need? But now before that, so how many network cards total? Now that's a small network. Let's say how many network cards I need? 4 multiply 5, because I have each computer needs 4, and I have 5 computers. How many network cards I need? 20. That's a lot. Connection. Let's talk about connection. So here, how many connection total you need? It's 10 links. Butler's equation. So usually the equation, if I remember correctly, it's n minus 1, which is equal. For example, how much the n here? 5 multiplied by 4, no. I think over 2 maybe, then over 2. So let's say 5 multiply 4 over 2, how much? 10. All right. So now we are talking about 5 computers. Now, in this universe, how many computers do you have? 1,000? 500,000? That's 1,000? Now if you're going to use the what they call it, the mesh, how many network cards do you need in my computer? It's 999. So it's not useful for the old. So what about the star? The star mostly what we are using now. So everything is connected to switch, and a switch direct the traffic to the right destination. Or we can use router. And we will see what's the difference between a switch, router, hub, all this stuff. We'll see it later. Okay, then, and again, those nobody really use, so I'm not gonna really explain. So the ring, if you're trying to send something from this host to this host, what can happen? You send it through the ring. So then each host will take it, open it, read the address. Oh, that's for me. I will keep it. If it's not for me, what I will do, put it back and put in the link and send it to the next one. So it's gonna go from this host to host and to reach to the right host. So there is a limitation, there is disadvantage. So now most of the technology is the star, either hub, switch, router, and we will explain that. All right. And we talk about the local area network. What's the local area network? It's a limited area, correct? It's limited now. Maybe it's a private. So for example, some of the organization, even they don't have access to outside. They don't have access for the internet. So they make it really private, secure. They communicate internally between each other, but nothing is going outside. Or you can communicate to the internet or to another local area network. And again, all of them, all the local area network hosts, they have to have the same network ID. Then they will have different host ID. Both together, it's the IP address, all right? What else? We talked about that already. So I'm not gonna waste your time. And we talked about the WAN. So the WAN, it's multiple local area network. So connected through a device. So maybe it's 10, 20, 100. So it's more than one local area network connected together somehow. And to make it bigger, the internet, what's the internet? It's everything. So you know, my internet at the house is connected to a provider, internet provider. I'm connected to Spectrum, right? And that's what we call that. We call the local, where is this one? Like a local ISPN, like provider network. And somebody in India, they connect to another internet company. So we have another provider. Then those region provider, they will connect to, for example, a country provider. And this country connect to another country using another provider that connects more countries together. So that's the internet. So that's my house. I'll connect to the Spectrum, connect them to the backbone. This backbone connect me to different countries. So all of us, we communicate. We are in one world now. I can send a message now from here to anybody anywhere without any problem. Of course, there is some problem, maybe bad connection, lost packet, but there is a way to correct that, right? Okay, let's go to, I'm not gonna spend a lot of time in the history, guys, because it's really boring and you can read it. And mostly, I will not ask you about it, all right? All right, so how the internet started or the network started? Before 1960, there is no something called network. There is no two computers communicate to each other. It's just a standalone computer, right? So at that time, of course, what they call it, the Department of Defense, they start concept, okay, how we can make a connection between two hosts or three hosts or four hosts. So that was like a dream. So they start a program, which they call it ARPANET. So they start with the ARPANET. And ARPANET is part of the Department of Defense. It was maybe a secret program, but they start the concept and they try to start the connection, and they achieved by 1967, okay, they call it Association of Computing Machinery. So they present the ARPANET, and they try to use a protocol. They build a protocol. They call it Interface Message Protocol. And they worked during the few years. And by 1969, what's happened? They've been able to connect four computers together. Okay, it was a long process to be able to connect 4 computers. And if you see, one computer was in University of California on one of the campus, and that second one, different campus. Then Stanford University, they have it, and University of Utah, they have the 4th one. And what they used at that time, they built a protocol. They call it Network Control Protocol. Right? It was really simple, and they had a lot of challenge. What's the challenge? What do you think the challenge at that time? Yes, the problem at the time, they don't have a standard. Like, you know, some of the computer, they send data with different rates. Okay, then the other destination could not handle it. Like, you know, I have a fast computer, I'm sending the data. The other end, slow computer cannot handle the data. So they had too many challenges. So what they did at the time, they built something between that. They built something called gateway. So the gateway, it's kind of the middleman tried to tweak it to be able to communicate. And these 2 people, you know, Bent and Bob, they worked hard on that. And in 1973, they introduced the TCP paper. You know, TCP, which is now the main protocol, TCP/IP. So at that time, the TCP in 1973, and in 1977, so the IP protocol came to the market, TCP. Then after that, by 1983, okay, ARPANET's gone away, and they start using TCP/IP protocol. All right, so that's the start. Still, they worked hard on that. And again, at the same time, there is another organization we're working on the same idea, trying to connect computers. So one of them is the MailNet, which is military. It's part of ARPANET. And then there's another one is CNNet. And finally, 1991, okay, the government established something called ANSNet. That's the final one. And that's to make sure you have a high-speed internet. So before 1991, they have connection. They established, they built the internet. I'm sorry, the network. However, it was not high speed. So in 1991, you know, with the ANSNet, they've been able to establish the high-speed internet. All right. Any questions so far? History? Okay. All right. So what's the internet today? You know, it's obvious. It's connection between LAN, WAN, everything. Okay. What's the www? You know, that's what we use now. That's almost everything now using the www, and that's came to the light, or you know, it's 1990, and that's how. Okay, that's just history. You can go over it. I'm not gonna waste your time on that. What's the time now? Want to take 10 minutes break? Fine. Or we need me to continue? Okay, let's take 10 minutes. Today I will try my best to finish early, so I'm not gonna give you a long class today. I will try to finish this chapter. I'm not gonna go over chapter 2. I will leave it for next week. All right, guys, I will see you at 7:12.